Good afternoon. Today we'll be discussing Raspberry Pi Lesson 4, given by Baking Pi from the University of Cambridge. Um, this lesson is a lot like Lesson 3, if you'd like to take a look at the video I posted for that. It's under Pi Lessons Lesson 3. Once again, we're just focusing on making the light on our Raspberry Pi, the ACK light, at pin 16 flash. GPIO, slightly different, but for the most part it does the exact same thing. And we're not really going to get into it because last time I talked for a lot longer than I thought I did. So I won't make you sit through that again. If you'd like kind of a rundown of what's going on here, this code will be posted to my blog, fully commented, as well as you can watch the video from Lesson 3. It's really similar, a lot of the same commands, kind of explaining how they're working and what they're doing. The main difference that we're focusing on in this lesson is in Lesson 3 we introduced GPIO in order to provide a function to set the pin. And so, which we took away from the main function as it was set in Lesson 2 and Lesson 1. And then in this lesson, what we're adding to that is that we're now going to have a function for doing the timer. Where in Lesson 3, around this area, we had a function that was looping, and it was saying if it's currently a 0, pass a 1. If it's currently a 0, we'll turn the light on, and if it's currently a 1, we'll turn the light off. Exact same thing going on here. You can see we're passing 0 and 1, but instead of doing the loop inside the main function, before I think we were also passing 3F 0 and then followed by zeros or something along those lines. Now it's just going to flash a little bit faster. But we're doing essentially the same thing, but instead of doing it here, we're branching out to this wait function. And the wait function is now in systemtimer.s. And as you can see, if you recall from the previous lessons, or if you're looking at the code from the previous lessons, really similar looking thing. We're passing it this value here, which is simply made to be a countdown. This time is equivalent to, it is, as you can see, 100,000 microseconds, which means that the light should flash on and off about 5 times per second. So 5 million or 1 million microseconds, I guess, is 1 second. So we can obviously see we're passing that over here, and we start to count down, and we're subtracting from that value just a single just a single value at each time. If we're not yet even, we're looping back, and it's still staying on or off depending on its current state. But really, again, extremely similar to what we saw in lessons 2 and 3. It's just this time we pulled it out of the lesson, or out of the main.s, and put it into its own function. Programming of any sort is better when you can really break things up. It allows you to kind of have a smaller margin for error. If all of this is also included in the main.s, this could have an error. Most of this could be working, but I would have to test everything within main.s to figure it out. Where now, if there's something just wrong with the timer, I can just come into system timer and change something in here without having to really deal with my main.s code, assuming that that's right. So we're going to go ahead and we'll build this. So we'll go back into our command prompt as usual. Our paths are still built in and everything. If you remember me from lesson 3, I said how the make file is not really made for Windows. operating systems. So one of the things I've been running into an issue with is that when I go to build, a lot of the times I'll get an error because what was happening was it was building the build file. Then it would run through once, it would build GPIO.O, but when it would go to build main.s, or as well in this case system timer.s, we were getting an error because it was trying to build the build file again, which of course already existed. The way we're getting around this is by hacking the system, really, deleting the building of the build file within the make file and building a directory called build ourselves. So if we just run a dir, we can see we already have a build file, where in lessons 1 and 2 this was really like a no-no. If you had that build file, it wouldn't build. Here we're going to intentionally insert it because we're not going to do that during the make process. So we'll just run pymake. You can see we build GPIO, we build main.o, and system timer.o, and they all go into the build file. And so now we will just place that onto our Raspberry Pi, and I'll show you how it builds.